Welcome students, I am Dr. Smita Sharma and I was teaching in the previous lecture about operational amplifier. Previous lecture, the topics covered were basically IC op-amp was discussed, its schematic symbol, equivalent circuit was shown, and various types of IC op-amps available in the market that are commonly used were discussed. Among them were IC 741, they were briefly described, LM324, etc. Now in this lecture, we'll discuss in detail about IC 741 because it is generally used, it is commonly used in labs and small projects. So IC 741, what is this basic IC? The 741 op-amp IC is a monolithic integrated circuit comprising of a general purpose op-amp. It was first manufactured by Fairchild Semiconductors in the year 1963. Generally IC 741 is written as mu A741. Mu A is the symbol of Fairchild Semiconductors company. The number 741, what does that means? This indicates that operational amplifier IC has 7 functional pins. 4 pins are capable of taking input and there is one output pin, hence the name 741. IC 741 op-amp can provide high voltage gain and can be operated over a wide range of voltages, which makes it the best choice for use in integrators, summing amplifiers and general feedback applications. As the students know, they generally use it in lab. It also features short circuit protection and internal frequency compensation circuits built in it. So IC op-amp comes in following form factors. Let's see the diagram. Generally, IC op-amp is encapsulated in three forms. First is 8-pin DIP package, dual inline package. Second is TO58 metal can package, and third is 8-pin SOIC package. Third part is the smallest packaging that can be made for IC 741 op-amp. So first of all, we'll see the pinout of IC 741 op-amp. So these two are pinouts of 741 IC. As we can see from the diagram, it has 8-pin DIP package or TO58 metal can package. Both are shown in figure. We'll discuss these pin configuration in detail. So functions of different pins of 741 IC. Again we have a 741 IC pin out diagram. Now for pin 4 and pin 7. So where is pin 4? Pin 4 and pin 7. As you can see, here it is written V plus power and here it is written V minus power. So pin 7 and is the positive voltage supply terminal and pin 4 is the negative voltage supply terminal. The 741 IC draws in power for its operation from these pins. The voltage between the two pins can be anywhere between 5 volts and 18 volts. So these two pins are basically are used for in adding power supply to the IC op-amp. Next is pin 6. Now here again pin 6, here it is written output. So pin 6, this is the output pin of IC741. The voltage at this pin depends on the signals at the input pins and the feedback mechanism used. If the output is set to be high, it means that voltage at the output is equal to positive supply voltage. If there is no feedback, then output is set to be high if the voltage at the output is equal to positive supply, that is plus V. Similarly, if the output is set to be low, it means that voltage at the output is equal to negative supply voltage. These two conditions are only when there is no feedback mechanism. Now next is pin 2 and pin 3. So pin 2 is here, it is written inverting, and for pin 3 it is written non-inverting. So these are the input pins for the IC. Pin 2 is the inverting input and pin 3 is the non-inverting input. If the voltage at pin 2 is greater than pin 3, then the voltage at the inverting input is higher and the output signal stays low. Similarly, if the voltage at pin 3 is greater than voltage at pin 2, then the voltage at non-inverting input is high and the output goes high. As you can see from the pin diagram, we generally, the symbol of IC op-amp is a triangle with two inputs and one output. So here it is made a triangle with two inputs in 2 and 3 and output is taken from 6. Next is pin 1 and 5. So pin 1, here it is written offset null, and for pin 5 it is also written offset null. Because of high gain provided by 741 op-amp, even slight differences in voltages at the inverting and non-inverting inputs caused due to irregularities because of manufacturing processes or any other external disturbances, it influenced the input. To nullify this effect, an offset voltage can be applied at pin 1 and pin 5 and is usually done using a potentiometer. So what does that means? Because it has this op-amp is very high gain amplifier, if slight regularity exists between pin 2 and pin 3, in spite of giving small similar voltages, if there is slight difference due to any reason, the output immediately drives to because of high gain, it immediately drives to plus power supply or minus power supply, either plus V or minus V. To nullify this effect, if we know generally there is small difference in manufacturing, however how much we try, but there is some irregularities between the manufacturing of the two stages. So always there is a possibility that there will be some irregularity between the two inputs. So without giving any input, there will be output, and that output will be very much high because of high gain. So in order to nullify this effect, we can apply a potentiometer between 1 and 5 to null out this effect created due to manufacturing irregularities in manufacturing or any other external disturbances. Now we are left with the pin 8. So if we see pin 8, it is written not connected. So pin 8, this pin is not connected to any circuit inside 741 IC. It is just a dummy lead used to fill the void space in standard 8-pin package. So there is no connection to pin 8. It is only to maintain symmetry it is given here. So these are the functions of different pins of 741 IC. Now let us see the internal schematic of IC 741. What is inside IC 741? So let us see the diagram of this is the diagram of 741 IC as seen inside. So it basically consists of 2 transistors and 11 resistors. All of them are integrated into a monolithic chip. So it is a very complicated circuit. So here we can see they are named Q1 to Q20. These are all transistors, and various resistors are there. 11 resistors are there of various values. Clearly 2 and 3 are mentioned. 3 is here and 2 here is here. If we see that it starts with a differential amplifier, then it connects into another differential amplifier and so on. So this is basically designed on a single chip. Now we'll see the electrical parameters, the parameters which are essential part of 741. It is not only for 741, these parameters are essential for all types of IC op-amps. We'll discuss one by one. First is input offset voltage. Now what is input offset voltage? It is the voltage that must be supplied between the two input terminals of an op-amp to null the output. Now we have seen that because IC op-amp has this 741 has very high gain. If there is slight mismatching between the two input terminals, there will be a difference in input voltage, and this difference in voltage will be multiplied with their gain and we will get an output. So what we will observe that without giving any input there is output. So input offset voltage is basically that voltage that must be given between two input terminals so that output becomes 0. As shown in figure, VDC1 and VDC2 are the DC voltages and RS represents the source resistance. We denote input offset voltage by VIO. This voltage could be positive or negative, therefore the absolute value is listed on the data sheet. So it is what does that mean? On data sheet provided by the manufacturer, VIO is the value is only absolute value is listed, it is not marked positive or negative. It's because it can be positive or it can be negative. For IC 741, its value is 6 millivolts DC. The smaller the value of VIO, the better the input terminals are matched. So by seeing the data sheet, we can decide that which type of op-amp. For 741 it is 6 millivolts. For other op-amps it can be other value. So by watching this we can decide which op-amp is better to reduce the effects of input offset voltage. Now we'll discuss. This is input offset current. Now first we'll go through the definition. The algebraic difference between the currents into the inverting and non-inverting terminals is referred as input offset current. So the current flowing, let us consider the current flowing through the non-inverting input is IB1 and the current flowing through inverting input is IB2. Then what will be input offset current? It will be IB1 minus IB2. So as seen from the diagram, we can calculate input offset current. Now for 741, this input offset current is 200 nanoamperes. As the matching between two input terminals is improved, the difference between IB1 and IB2 becomes smaller and this value reduces further. So this value is also written on the data sheets provided by the manufacturer, and if there is large difference between IB1 and IB2, it means that the two input stages, what does that mean? Because the first stage of an op-amp is generally a differential amplifier. So there are two stages of the differential amplifier and they should be completely identical. If there is large difference between IB1 and IB2, it means that the two stages of the differential amplifier are not completely matched. So this value should be very small for better operations. Next is input bias current. Now, how we will define it? It is the average of the currents that flow into the inverting and non-inverting input terminals of the op-amp. So, that was IB1 minus IB2, input offset current. Now, input bias current is IB1 plus IB2 upon 2. It is the average of the currents that flow between inverting and non-inverting input terminals of the op-amp. For 741, its value is 500 nanoamperes. Now next electrical parameter is differential input resistance. First definition, it is the equivalent resistance. What is it? This is the equivalent resistance, which means that if we remove the various parts of the op-amp then and replace it by some resistance, then what value of resistance should we place? It is the equivalent resistance that can be measured at either the inverting or non-inverting input terminal with other terminals connected to ground. So if we are flowing current through one of the we are providing input signal from either inverting end or non-inverting end, and we are putting other terminals to ground, then the resistance measured is known as differential input resistance. It is denoted by Ri and is often referred as input resistance. It is also called input resistance in simple way. And for 741, it is relatively very high. It is approximately 2 mega ohms. So this will be an extra additional benefit for op-amp, as we will see further. Next parameter that we will discuss is the input capacitance. Again, its definition is it is the equivalent capacitance that can be measured at either the inverting or non-inverting input terminal with other terminals connected to ground. It is represented by Ci and is often referred as input capacitance. Now for 741, its value is 1.4 picofarad. So the next important parameter is offset voltage adjustment range. One of the features of 741 family op-amp is an offset null capability. We have seen in the pin out configuration that what we had seen that pin 1 and pin 5 are used for offset null purposes. So in the diagram you can see one pin and 5, between pin 5 and pin 1 a potentiometer is connected with, and its movable end is connected to with the negative supply. As shown in figure, a 10k ohm potentiometer can be connected between offset null pins pin 1 and 5, and the wiper of the potentiometer can be connected to the negative supply minus VEE. By varying the potential, the output offset voltage can be reduced to 0 volt. So see, when we without applying any input, if there is some output, that output is not required, because that output is only due to irregularities or mismatching between pin 2 and pin 3, or we can say the two stages of a differential amplifier. So for a zero input, there should be zero output. This can be made by using this potentiometer. We nullify the effect by moving the wiper of that potentiometer till for zero input there is zero output. Thus, the offset voltage adjustment range is the range through which the input offset voltage can be adjusted by varying the 10k ohm potentiometer. For 741, the offset voltage adjustment range is plus minus 15 millivolts. So, generally this can be adjusted. Now, the next is input voltage range. When the same voltage is applied to both input terminals, the voltage is called common mode voltage, VCM, that we have discussed in detail before, and the op amp is then said to be operating in common mode configuration. For 741, the range of input common mode voltage is plus minus 13 volts maximum. This means that common mode voltage applied to both input terminals can be as high as plus 13 volts and as low as minus 13 volts without disturbing proper functioning of the op amp. If the voltage flickers above plus 13 or minus 13, then the proper functioning of the op amp is disturbed. Now, this we have common mode rejection ratio. This we have discussed in detail in the previous lectures. For 741, here we will not discuss common mode rejection ratio. For 741, we'll simply remember that CMRR is 90 decibels. We have earlier studied that CMRR is generally expressed in terms of decibels. Now, one more important parameters that is associated with an IC op amp is supply voltage rejection ratio, CVRR. The change in an op amp's input offset voltage caused by variation in supply voltages is called supply voltage rejection ratio, CVRR. For 741, CVRR is 150 microvolts per volt. Another important parameter is slew rate. Now, what is slew rate? Slew rate is generally abbreviated as SR. It is defined as the maximum rate of change of output voltage per unit of time and is expressed in volts per microsecond. The slew rate, when we will discuss op amp frequency response of an op amp, then this factor will be very important. It indicates, what does that slew rate, why this parameter is important? It indicates how rapidly the output of an op amp can change in response to changes in the input frequency with input amplitude constant. So basically it shows the ability of an op amp, how rapidly the output is changing with the changes in input frequency. It changes with change in voltage gain and is normally specified as unity gain. This we will discuss in detail after in other lectures. It is one of the important factors in selecting the op-amp for AC applications, particularly at high frequencies. 741 has a low slew rate. It is generally 0.5 volts per microsecond. So these are some of the parameters that we have discussed we have discussed and defined what does these parameters mean and what are its value for a 741 IC. Now these parameters will be used in coming discussions, in coming lectures. Now in the next lecture we will discuss how 741 IC op-amp. Generally we will discuss 741 IC op-amp, but we'll drop the name. We'll only discuss op-amp and we will discuss open loop configuration of an op-amp. So what does that mean? Before discussing open loop configuration, one more parameter is we will discuss, that is gain bandwidth product. Gain bandwidth product is the bandwidth of the op-amp when the voltage gain is 1. This we will discuss when we will study feedback amplifier in detail. Now here we'll only work out the definition. It is basically the bandwidth of the op-amp when the voltage gain is 1. For 741 op-amp, it is not listed under electrical characteristics and it is generally calculated from open loop voltage gain versus frequency graph. It can be found approximately to 1 megahertz. So now basically we have discussed mostly all the electrical parameters of the 741 op-amp, and there we have discussed the general definition of these electrical parameters. Now in the coming lecture we'll discuss open loop configuration of the operational amplifier. How does operational amplifier works and how it should be used so that it can be used for a useful purposes or for operational amplifier for which its name is given. So by winding this lecture we'll see again IC 741 specifications. The basic specification of IC 741 is power supply. It can be minimum 5 volts and can withstand up to 18 volts. Its input impedance is high, approximately 2 mega ohms. Its output impedance is low, 75 ohms. Its voltage gain is 200,000 for low frequencies, 2 into 10 raised to power 5. Its maximum output current is 20 milliamperes. The output load that is recommended is generally 2 kilo ohms. Input offset ranges between 2 millivolts to 6 millivolts, and slew rate, as we have discussed before, is 0.5 volts per microsecond. Because from seeing through the specification, the high input impedance and very small output impedance makes IC741 a near ideal voltage amplifier that we will see in coming lectures. Thank you.